This is a continuation of pre-calculus skills with parametrics, and I'm going to kind of fly through this. I think we got a pretty good handle on it. I hope so. Maybe I won't even graph all of the stuff, but the conversion to Cartesian is a little bit different on this. Okay, let's start with getting a little table here. So let's start. We got 0. Now you notice that of course we got cosine, sine, so I'm going to limit myself here to like really easy ones. Pi over 2, pi, 3 pi over 2, just like that, okay? So let's start with x equals sine. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. Okay, cosine. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. All right, so if I were to graph this, let's change this. Let me make the graph big. Okay, let me just do that. Okay, so it goes here. Okay, that's well, I guess the initial point is right here. Initial point. And it is going to be a circle. Okay. Now, here's the key. Whenever you see something like this, because Cartesian, I mean, this is kind of hard. Now, Cartesian is in terms of x and y. It doesn't say put it in a y equals, because that's not always possible. But here's the key. Remember that x squared plus y squared equals 1. That's the key to this whole thing. Well, think if you squared this and squared this and then added them together. Cosine squared, sine squared is x, or sine squared is x squared, cosine squared is y squared. So there we go. We got sine squared plus cosine squared, and that's always equal to 1. So this is the Cartesian form. That's the x squared plus y squared thing is the key to this. I guess, excuse me, the sine squared plus cosine squared thing is the key to this. Okay? All right. Next, let's do 3 sine t and 4 cosine t. So from 0 to 2 pi. So I'm gonna do the same exact t values. 0, pi over 2, pi, 3 pi over 2, and remember 2 pi would just be back at the beginning, so it would be the same as 0. Okay. So x, 4 multiplied by the cosine of 0 is 4. 4 times the cosine pi over 2 is 0. This would be negative 4, and this would be 0. Okay. Y, 3 sine t, well the sine of 0 is 0, so it's 0, 3, 0, negative 3. So the first point is 4, 0. Next point, 0, 3. Then we got negative 4, 0, and 0, negative 3. It's an ellipse. Okay, and I should label the initial and terminal point are the same, because it goes from 0 to 2 pi, so it would come back to where it started. Well, here, if you remember your ellipse stuff, I'm going to divide both sides by 3. Now, I don't have much room, so let me just write that over here. Sine equals y over 3. So cosine is equal to x over 4. And then we do the same exact thing where we square everything. So again, sine squared plus cosine squared is 1. Well, that must mean that y over 3 squared plus x over 4 squared is 1. Okay, let me just say that again. Y over 3 is the same as sine, so sine squared plus x over 4 is the same as cosine, so cosine squared is 1. This is where we get that equation from pre-calc, y squared over 9 plus x squared over 16 equals 1. The equation of ellipse. Okay. Instead of graphing this last one, just in the interest of time, let me just say one more time how we would get the Cartesian here. We use that sine squared over cosine, or sine squared plus cosine squared, so divide both sides by 2. Let me just write that sine is equal to y over 2. But cosine is just x, so we'll have sine squared, so y over 2 squared, plus cosine squared, so x squared equals 1, so y squared over 4 plus x squared equals 1. I guess because I didn't graph it, just pay attention here to the fact that it's only 0 to pi, so there will definitely be an initial and terminal point because it's not even making the whole ellipse. Okay, so we covered a lot here. We covered why, in these videos, we covered why you need parametrics. Okay, it's to map an entire path with both horizontal and vertical components. We covered how to graph them using a table. Okay, remember t does not appear, you're only using x and y. We covered how to label the initial and terminal points using the domain of t. And we covered how to convert them to Cartesian equations, both nice ones where we just solve for x, or t equals in the x equation and substitute, and ones that are a little more interesting, ones where we have to use some trigonometry. So here it is. This is all the pre-calc skills we need to jump into the calculus of parametrics.